Hi everybody. So here are your little paper strips that you kind of put together into groups. Hopefully you've put them into 4 groups and 4 groups. So I picked these to put them all together because they have the word acid in them. I put these together because they have Roman numerals. I put these together because they have prefixes right here, and then I put these together just because they didn't have anything else special about them. So if you look at these groups, these right here are covalent, and you can tell that because they all have metals non-metals. These are all ionic because you have a metal and a non-metal. These are also ionic, but they have transition metals, and we're going to talk about that a little bit later. And then these are acids because they have the word acid in them. So we're going to start first talking about covalent compounds. So we're going to talk about these here, where you have 2 or more nonmetals bonded together. So we're going to focus on these, and we want to come up with rules for the naming of the compounds. And so, for example, N2O5 is dinitrogen pentoxide. S3F8 is trisulfur octafluoride, and SCl6 is sulfur hexachloride. So if I wanted to write some rules for how to write a name, if I were given the formula, so if I were given these, how would I write the name? So I would start by writing the name of the first element. Then I would write the name of the second element, but notice that there's an IDE ending for all of them. So you want to write the name of the second element and end it with IDE. So chlorine becomes chloride, fluorine becomes fluoride, oxygen becomes oxide, and so on. Then you want to add prefixes to tell you how many atoms there are. So let's go over the prefixes real quick. For the prefixes, 1 would be mono, 2 would be di, 3 is tri, 4 is tetra, kind of like tetrahedral or tetras, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. And you do need to memorize these prefixes. You use the prefixes for both the first element and the second element, except if it's mono, then you don't use it for the first one. So for example, right here, it would be sulfur hexachloride as opposed to monosulfur hexachloride. Although if you put monosulfur hexachloride on the test, that would not be incorrect. It would not be marked wrong for you. So let's try some the examples here. So we want to give the formula for the following. So sulfur dioxide, so sulfur would be S, dioxide, oxide is oxygen, and di tells us that there's 2, so it's SO2. Dinitrogen pentoxide, so nitrogen is my first element, oxide is oxygen, di tells me there's 2 nitrogens, and pentoxide tells me it's 5. Phosphorus pentafluoride, phosphorus is P, pentafluoride means fluorine, and there's 5 of them, so PF5. Dihydrogen monoxide, so hydrogen, and di means 2. Monoxide, oxide is oxygen, and it's only mono, so that's 1. So actually, the real name for water is dihydrogen monoxide. Trisulfur heptachloride, so sulfur is S. Tri means there's 3 of them, so S3. Heptachloride, chloride is Cl. Hepta means 7, so S3Cl7. Triselenium octahydride, Se. Tri means 3. Octahydride, hydride is H. Octa means 8, so Se3H8. Now we want to do the opposite. We want to write the name from the formula. So P3F7, so that's phosphorus. And fluoride. So write the name of the first element, write the name of the second element with IDE, then add prefixes. So there's 3 phosphoruses, so triphosphorus, 7 fluorides, so hepta. So it is triphosphorus heptafluoride. SiO2, Si is silicon. Oxygen would end up being oxide. Add your prefixes. So since there's only 1 silicon and it's at the beginning, we don't need to put mono. O2 would be di, so silicon dioxide. Next one is CO, so carbon, and then oxide. 1 carbon at the beginning, so you don't need to put anything. And then oxygen, there's only 1, so you put monoxide. So for the mono, you put it when it's the second element, but not with the first element. N2O5, so nitrogen. And then oxide again. There's 2 nitrogens, so dinitrogen. And then 5 oxygens, so pentaoxide. You can write pentaoxide or pentoxide, both are okay. All right, now we want to look at particle diagrams for covalent molecules or covalent compounds. So we want to write the IUPAC name. So IUPAC name is basically the name that's accepted. IUPAC stands for International Union of Pure and Applied Chemistry. So basically the rules that we've just went over, those would be the IUPAC rules for naming covalent compounds. So you would write hydrogen, name of the first element, then name of the second element, so oxygen would become oxide, and then add your prefixes, so dihydrogen monoxide. Then we want to draw a particle diagram for 1 molecule of water. So you have an oxygen and then 2 hydrogens right here. It's called the Mickey Mouse molecule. We know that it's bent, so try to draw it bent. If you forget and you put it all in a line, that's okay. How many atoms does it have? So for every 1 molecule of water, we have 3 atoms, 1 oxygen and 2 hydrogens. Let's try tetracarbon decahydride. So the formula for it, carbon is C, hydride would be hydrogen, and tetra means 4, so C4, deca means 10, so C4H10. We want to draw a particle diagram for it. I'm going to do it right here because I don't have very much room. So there are your 4 carbons. And then, oops, that's a carbon there, sorry. And then we have 10 hydrogens. So 1, 2, 3, 4, 6, 7, 8, 9, 10. And so label all these as hydrogens. And I'm sorry, the stylus is kind of hard to write with. Obviously, you would write it much neater. How many atoms does it have? That would be 14 atoms total for 1 molecule of carbon, or sorry, tetracarbon decahydride. Next, we're going to look at the ionic compounds, and we're only looking at the ionic ones without the transition metals here. So we have this formula is barium nitrate, this one is aluminum bromide, and this one is lithium carbide. So let's come up with rules for writing the name for an ionic compound. Again, these are IUPAC rules. So I would start by writing the name of the first element. Which would be your cation. Next, write the name of the second element. And we want to end it again with IDE. Except if it's a polyatomic ion. Then you leave it as is. So for example, this is carbon right here, so we end it with ide, so carbide. This is bromine, so you end it with ide, so bromide. But this is a polyatomic ion. This is the nitride ion, so you keep it as is with its name. And then that's it, no prefixes. So you name ionic and covalent the same way. You write the name of the first element, then write the name of the second element, end it with IDE. If it's covalent, you add prefixes. If it's ionic, it's actually easier because you don't add anything. You just stop there. So let's try some examples. So sodium nitride, we want to write the formula for it. Now, this is ionic, so you have to be careful with ionic. They don't give you the prefixes for how many there are. So how would you know how many there are? Remember, all compounds have to be neutral. So you have to make sure that your charges balance out because you have cations and anions here. So sodium nitride, that would be sodium ion, which is Na+. Nitride is N3-. So now to put it together, you'd need 3 sodiums and 1 nitride so that there's 3 pluses and 3 minuses so that it's neutral. Let's try the next one, lithium oxide. So lithium ion is Li+, oxide would be O2-. So to make it neutral, you would need 2 lithiums and 1 oxygen, so Li2O. Next is barium hydroxide. So barium has a charge of 2+. Hydroxide, if you remember, is OH-. It's a polyatomic ion. So then you would need 2 hydroxides for every 1 barium. So it's BaOH. Then we need 2 of those, but remember, if it's a polyatomic ion, you put it in parentheses and then a 2. Let's do the next one. Magnesium selenide. So magnesium ion is Mg2+. Selenide, that's selenium ion. That would be 2-. So it would just be MgSe because it's 2+, 2-, so that's neutral. Next one is ammonium carbide. Remember, ammonium is a tricky one. Ammonium is actually not on the periodic table. It's a polyatomic ion. It's NH4+. Carbide is carbon with 4-. So to make it neutral, you'd need 4 of the ammoniums. So to write that out, kind of running out of room here, I'm going to write it underneath. So NH4, parentheses, 4 of those, and then carbide. Next one is aluminum sulfate. So aluminum ion is Al3+. Sulfate is another polyatomic ion. It's SO4 2-. So this one, we actually need 2 of these and 3 of these. So the formula would be Al2SO4 3. All right, now we're going to do the opposite. We have the formula, and we're going to write the name. So with these, you write the name of the first element, then the name of the second element, end it with ID unless it's a polyatomic ion. So for this one, that would be sodium, is the name of the first element. Then this right here would be phosphorus, so we change it to phosphide. And that is it. You leave it as is, no prefixes. Next one, this is calcium. And then this right here is a polyatomic ion. This is nitrite. Again, no prefixes, you leave it as is. Next one, this is lithium. And then this is a polyatomic ion. That's hydroxide. This one right here, lithium again. And then this is a polyatomic ion, that's sulfite. Next one, this is aluminum. And then this is a polyatomic ion, this is cyanide. Okay, so with ionic, just be careful when you write the formulas, you have to make sure that it's neutral. So now we're going to take a look at particle diagrams of ionic compounds. So they're similar to the particle diagrams for the covalent, except because these are ions, you have to show the charges in your circles when you draw your particles. So we want to sketch the ionic compound formed by aluminum ion and fluoride ion. This is number 2. So we're going to start with aluminum ions. So we have an Al3 plus side of a circle, and then a fluoride ion, that's F minus, but then that's not neutral, so we need another F minus, still not neutral, another F minus, and now it's neutral. What's the formula of the compound? That would be AlF3. Remember, the positive or the metal always goes first, then the nonmetal. What's the name of the compound? So since it's ionic, you name the first element, so aluminum. Name the second element with IDE, fluoride, and then you just leave it as is. How many atoms does one formula unit of this compound contain? Remember, a formula unit is the same thing as a molecule, except molecule is used for covalent, formula unit is used for ionic. So in one of these, there are 4 atoms or 4 ions. Okay, let's do number 3. We want to sketch the ionic compound formed by aluminum ion and oxide ion. So aluminum ion is still Al3 plus, oxide is O2 minus, but it's not neutral, we have too many positives, so add another O2 minus. Now we have too many negatives, so add another Al3 plus. Now we have too many positives, so add another O2 minus. And again, it doesn't matter how you arrange these. You can put them on top of each other or in a circle or whatever. The formula for this compound, remember your positive or the metal goes first. So Al, we have 2 of those. And then O, we have 3 of those. So Al2O3. The name of the compound would be aluminum oxide. Okay, let's do another one. We want magnesium and nitride. We want to sketch that. So magnesium has a 2 plus charge. Nitrite is a polyatomic ion, NO2 minus. So to make it neutral, we'd need another one of those, one of the nitrites. So the formula for the compound would be Mg, just one of those, and then NO2, there's 2 of the NO2, so you put it in parentheses, and then a 2 outside. The name of the compound would be magnesium nitrite. And for how many atoms does one formula unit of this compound contain? This one's a little tricky, so let's count here. We have 1 magnesium right there. Then remember, this distributes, so we have 1 magnesium, we have 2 nitrogens, and we have 4 oxygens, so the total would be 7. Okay. So just a quick summary. If you're naming a substance, you name the first element, Then you name the second element and end it with IDE. Unless it's a polyatomic ion, then you leave the ending of it as is. Then you check if it's covalent or ionic. Remember, covalent means nonmetals. Ionic means metal with a nonmetal. If it's covalent, you add your prefixes. If it's ionic, you leave it as is until tomorrow when we talk about the transition metals. But for now, you leave it as is. If you are trying to find the formula from the name, if it's covalent, the prefixes will help you figure out how many of each atom. If it's ionic, then you make it neutral by balancing out the charges. And that's it for today's lesson. So your homework for tonight is worksheet 1. Try to do your best on it, and tomorrow I'll answer any questions that you have. You guys have a great day.